A random variable x has a probability distribution given in the following table. So the x equals to 2, 3, 4, or 5. And the probability of x, random variable, to be equals to a particular value, small x, would be p. For x equals to 2, 2 over 10. For x equals to 3, and 3 over 10, x equals to 4, q will be equals to 5. Now we're given that the expectation of x is equals to 4. Right, we need to find p and q. So there are a few things that from the start, even before the question, there's some fundamental knowledge that first of all we know that the summation of the probability of capital X to be equals to x has to be equals to 1. This means that looking at the probability distribution function table or the PDF table, if we were to add all the probabilities together, this will give us the value 1. Alright, and simplifying this, we have p plus q. 1, bring 5 over 10 over, minus 2 over 10, minus 3 over 10, and eventually the outcome is that you have p plus q to be equals to half. Right, this gives you actually like one equation. Right, what else do we know? We also know that effect is given that the expectation of x is equals to 4. Right, this is given. Right, because this one is given, what does that know? You also know that the formula of expectation x means that the summation of x, the probability of x is equals to 4. This means that if I were to add up, I have 2 multiplied by p plus 3 multiplied by 2 over 10. So multiplying all the x values, right, this is equals to 4. Okay, and simplifying this gives us like 2p plus 6 over 10 plus 12 over 10 plus 5q equals to 4. 2p plus 5q should be equals to 11 over 5. Alright, and I mean just solving, you just need to solve equation 1 and 2. Okay, so just solve equation 1 and 2 on your own. Right, and eventually you can use a GC or whatsoever. You will get q to be equals to 2 over 5 and p to be equals to 1 over 10. Right, so 1 mark will go to you finding the first equation, second mark will go to you finding the second equation, and third mark will be like for here, solving the question, and final answer A1. A1 is for this. Alright, and this is for part 1, question 1, part 1. Okay, so next will be question 1, part 2. Alright, so show that the variance of x equals to 1. We're supposed to show that the variance of x equals, so variance of x, as we know, would just be equals to the e of x squared minus e of x whole thing square. Now we already know that this is actually equals to 4, right, from earlier part of the question, and e of x squared would just be it can be something that we can calculate ourselves. It would just be 2 square multiplied by p, and p is already found to be 1 over 10, right? So, and plus 3 square multiplied by 2 over 10 plus 4 square multiplied by 3 over 10 plus 5 square multiplied by q, and q as we found is 2 over 5, so it's just like that. Okay, then calculating this should give you the value of 17. Alright, then variance x will just be equals to ex squared, which is 17, minus ex whole thing square, which is 4 square, and it will just give you 1. Alright, and next part, part 3, we are supposed to find the expectation of the modulus of x minus 4. Alright, so what does this mean? So it really means that from the original values, remember we had 2, we had the x values which was 2, 3, and 4, and 5, correct? So now instead of looking at x, we're looking at the modulus x. So we are really looking at 2 is paired with the probability of p, which is 1 over 10, right? And 3 is paired with the probability of 2 over 10. 4 is paired with the probability of 3 over 10. And 5 is paired with the probability of q, which is 2 over 5. So now, basically what we do is we actually just need to multiply it, right? Because we are doing a modulus of x minus 4. So it is x minus 4. Alright, so 3, right? 3 modulus minus 4. 4 modulus minus 4. 5 modulus minus 4. That's basically what it means, that we just take all the x values and we mod it and we minus 4. Right? That's what the question really wants. E of mod is you take your data values, you minus 4, and then you modulus it. Alright, and then together with attached probability, this will just be like 2 minus 4 will be negative 2 mod negative 110 plus mod of negative 1, 2 over 10 plus 0, right? 0 mod 3 over 10 plus modulus of 1, 2 over 5. Alright, so modulus of that I believe you can calculate by on your own, and the answer will just turn out to be 4 over 5. Alright, so this is the expectation of the modulus of x minus 4. So basically what you do is you have all your data values, all your x1, x2, what you do is just mod it, minus 4. Right, mod it, minus 4. Right, and mod it, minus 4. Okay, so next one, the 10 independent observations, right, of x are taken. So what do you see from here? What do you think? I'm sure you are thinking about binomial, right? So this one actually suggests a binomial. Alright, suggests a binomial distribution. Okay, 10, so you know that n equals to 10. Find the probability that the value 3 is obtained not more than 3 times. So basically here, this is it's like we have a like y to be taken a binomial distribution of n comma p, where n is equals to 10, and this is the probability that y equals to 3. Right, so how, and not more than 3 times, right? Not more than 3 means what? At most 3, right? This must be what? Less than equals to 3. And here, how do you find the probability of y equals to 3? Right, so you can see the probability of y equals to 3 just over here, right? It's just equals to 2 over 10. So basically this is equals to 2 over 10, and this is equals to 10. Alright, so with that, first of all, you must remember that we always define the variable, or we'll say that we let y denote the random variable of the number of times out of 10 observations of x, alright, which 3 is obtained, which the value 3 is obtained, right? So basically y represents the number of times out of 10 observations of x which the value 3 is obtained, and then y will take on the binomial distribution of 3, 10, and the variable will just be 2 over 10, right? I mean the probability is 2 over 10. The probability that x equals to 3 is 2 over 10. And with this, using our binomial CDF function, alright, you just get your answer very quickly to be 0.879.